Good morning, students. Today, 8th class physics subject. The name of the chapter is force. Name of the chapter is force. Already in this chapter, we discussed types of forces. What are they? Contact force, non-contact force. Non-contact force also known as the force at a distance. Already I told contact forces, in that one free body diagrams also, and lab activity, that is the limiting force. Now we are going to discuss force acting at a distance. Force acting at a distance. What is the meaning of this one? This means is field force. Field force means not a touching force. What are the examples of the field force? First one, magnetic force. Magnetic force is the field force. Magnetic force is field force. Without touch, they can attract other iron, cobalt, nickel, gadolinium and dysprosium metals. And the second one is electrostatic force. Electrostatic force. Third one, gravitational force. Gravitational force. In this way, these all are the examples of the, what are they? Field force. Field force means force acting at a distance. Now, we are going to discuss the magnetic force. Have you know about the magnetic force? You all are very interested to play with the magnets. Why? Because of magnets attract the iron pieces, nickel pieces, gadolinium. Magnetic force, they attract the iron, nickel, cobalt, gadolinium and dysprosium. One metal does not attract the other metal, but magnet attract the iron, nickel, cobalt, gadolinium and dysprosium. In this one, that is the activity 6. Activity 6. What is the name of the activity 6? Observing the magnetic force. Observing the magnetic force. Take a needle, seeing needle. Kuttu sudi, kuttukune sudi. Take a seeing needle and rub it. What is this one? Rub it with the help of the magnet, North Pole, South Pole. Rub it with this direction. Rub it with this direction. What is this one? This is the needle. Now you rub it rub it with magnet in single touch method. After some time, this needle also become the magnet. When needle was rubbed with magnet with any one of the pole, it become the magnet. It become the magnet. How can it is become the magnet or not? How can we find it? How can we find it? First of all, take some water in a bowl. Take some water in a bowl. This is the bowl. This is the bowl. In this bowl, we have to take some water. Water with a bowl. Water with bowl. Okay. Here water is there. When we draw the needle in this water, you have confused. That's why I am going to rub the water in this one. We have to estimate. Water is there in this bowl. So here one needle is there. One needle is there. You kept one more needle in this one. Otherwise, when you kept the needle in this water, it will becomes in this direction. What is this one? Some directions are there for our land also. North pole, south pole, east, west. We need only the north and south. Why? Magnets are having the directional property. What is that one? When we left the magnet freely, it comes to rest. It comes to rest with the to showing the directions of the north pole and south pole. That's why this needle also comes to the rest. Comes to the rest to showing the north pole and south pole of the earth. Take some red color. What is that one? Red color. Red color. Red color. Red color. Thermocol. Thermocol ball. Red color thermocol ball here this side, and another white color thermocol ball this side. So red color thermocol ball shows the north pole of the magnet. White color thermocol shows the south pole of the magnet. This is north pole, it is the south pole. That's why the needle of the magnet also consisting the north pole and south pole. As like that, we have to kept one more magnet, needle magnetic needle here only. At that time, you noticed that this is the magnetic needle. Thermocol ball. This is the north pole, this is the south pole. When you kept one more magnetic needle, this is the north pole, it is the south pole. North pole, south pole. Both are not repel each other, not attract each other. So that's why same poles of magnets repel each other. Same poles of magnets repel each other. Repel each other means does not attract. Another, that is, one more thing is there. Take one more needle. This is the North Pole. It is the South Pole. And one more, another needle. This is the North Pole. It is the South Pole. This is the North Pole. It is the South Pole. This is South Pole, North Pole. Both are attracting each other. Both are attracting each other. Attract. Otherwise, is simple. Attract. Attract. Okay, so different poles of magnets attracts each other. Same poles of magnets repel each other. Different poles of magnets attract each other. That's why magnetic force attract near objects. So it is example for force at a distance. Force at a distance, which is magnetic force attract nearer objects. So it is example for the force at a distance or field force. Field force, like that only. What is this one? Force acting at a distance or field force. How many types of forces I told? 3 types. Magnetic force, electrostatic force and gravitational force. First force is attractive. Magnetic force. Magnet attracts the iron, nickel, cobalt, gadolinium, dysprosium. Activity 6. Observing the magnetic force. Already I told you, take one needle, rub it with the help of the magnet. It becomes the magnet after some time. And one pole. How can you identify the pole? The directional property of the magnets. What is the directional property of the magnets? When a magnet suspended freely or kept on the water freely, it will comes to rest to showing the North Pole and South Pole of the Earth. So that's why we can identify North Pole, South Pole of the needles. So North Pole represented with the red color and South Pole represented with the white color. Same poles, that means South Pole, North Pole repel each other. Different poles of magnets means North Pole, South Pole, North Pole attract each other. This is known as the field force. Magnetic force attract nearer objects. So it is example for force at a distance or field force. Have you understood? Okay. I am going to the board. Another one is there. That is the electrostatic force. What is the next one? Electrostatic force. Electrostatic force. In textbook, so many examples are given for the electrostatic force. Some of the live examples are there. What is that one? Dear students, you are identified some of the advertisements in TV also. A old man lose his 10 rupee note. It will be fly away by the air and it crossed the fencing. One schoolboy coming that side and he saw the 10 rupees note and he asked the plastic scale, Nataraj plastic scale from his friend. He rubbed that plastic scale with his dry air or his shirt or pant and he showed that Nataraj plastic scale to that 10 rupee note. That 10 rupee note attracted and touches with the plastic Nataraj scale. This is the advertisement. It is also best example for the electrostatic force. What is that one? Electrostatic force. What is the meaning of the electrostatic force? Electricity stayed on the surface of the body. That is known as the electrostatic force. What I told you? Electrostatic force. What is the meaning of that one? Electric current or electricity stayed at the surface of the body is known as the electrostatic force. The force exerted by a charged body on another charged body is known as the electric force. I am going to write that one also. What is that one? The force exerted by. What is that one? Exerted by a charged body. A charged body on another body. Another body means either charged or uncharged. Another body is known as electrostatic force. The force exerted by a charged body on another body is known as the electrostatic force. In your textbook page number 8, figure number 10. It is example. What is that one? He took one balloon, bulged balloon. Balloon means you know. In Telugu, this is known as, what is that one? Budaga. Yes, balloon. We have to blow the air into the balloon. It will be bulged. Okay, rub it with the help of the cotton cloth. Bulged balloon, rub with the help of the cotton cloth or silk pant, rub it. When it was rubbed, it will be chargified. When you kept nearer to a bulged balloon, nearer to the paper pieces or thermocol pieces, they will be attractive. This is the example for the, what is that one? Electrostatic forces. So that's why I am going to write that one example. What is that one? rubbed, charged balloon, rubbed, charged balloon attract small paper pieces or thermocol pieces. It is example for the electrostatic force. One more. One more example is chargified plastic comb also attract the paper pieces. So this is example for the electrostatic force. These all are the examples of the force acting at a distance. I will explain in next class about gravitational force. Okay, thank you.